3 nanometers, 2 nanometers, angstrom, the atomic boundaries are here. For over 5 decades, transistor density doubled every 2 years. Moore's law, the rhythmic metronome of the digital economy. Then physics fought back, thermal throttling, quantum tunneling, interconnect bottlenecks. The free lunch is over. A modern system on chip is the most complex artifact humanity has ever built. The design space for placing its components exceeds the number of atoms in the observable universe. The thesis of this brief is direct. Reinforcement learning is the defibrillator for Moore's law. Chip floor planning is no longer a static math problem. It is a sequential game to be played, and the agent now plays it better than any human team. Traditional electronic design automation rests on simulated annealing, an algorithm from the 1980s. It has 2 fatal flaws. First, it is memoryless. Every run starts from a random seed. It learns nothing from the previous chip. Nothing transfers from one design generation to the next. Second, it is trapped in local minima. In the rugged landscape of modern power, performance, and area metrics, it settles for good enough. Human engineers compensate by breaking the chip into blocks, divide and conquer. But blockwise optimization sacrifices global optimality. The result is the Manhattan layout, neat columns of memory, rectangles of logic, aesthetic artifacts of human cognitive limits, efficient for comprehension, inefficient for electrons. The shift is from heuristics, static rules, to learned intuition, dynamic policies. AlphaChip from Google DeepMind was the first rigorous demonstration. A deep reinforcement learning agent outperformed expert human teams on commercial silicon. The mechanism has 4 parts. First, the formulation. Chip floor planning becomes a Markov decision process. The state is the partial layout. The action is placing the next macro at a grid coordinate on a 128 by 128 canvas. The transition is deterministic. The reward is a negative weighted sum, alpha times wire length, beta times congestion, gamma times density, delta times timing penalty. The agent maximizes cumulative reward, which corresponds to minimizing the cost of the final layout. Second, the perception. A netlist is not an image. It is a hypergraph, an irregular web of gates and wires. AlphaChip uses an edge-based graph neural network. Embeddings are created for every node and every edge. Through multiple message-passing layers, a memory controller node learns that it is heavily connected to an arithmetic unit 3 hops away. Third, the decision. 2 networks read the embeddings. A policy network predicts the probability distribution over the next placement. A value network estimates the final quality of the chip from the current partial state. Fourth, the transfer. The agent is pre-trained on diverse blocks, memory controllers, TPU cores, PCIe interfaces, open-source RISC-V Aryan designs. On a new unseen block, the agent does not start from zero, it starts with intuition. Convergence to a superhuman layout takes hours, human teams take weeks. The proof is in production silicon. Google's 6th-generation Trillium TPU used AlphaChip across a larger proportion of its blocks. The result was a 4.7 times increase in peak compute performance and a 67% improvement in energy efficiency over the previous generation. MediaTek validates the approach outside the hyperscaler bubble. The Dimensity 9400 SoC, deployed in millions of Android smartphones, delivered 35% higher single-core performance, 40% better power efficiency, and a neural processing unit with twice the compute at 33% less power. MediaTek executives explicitly credited the reinforcement learning algorithms for optimizing the cache and memory controller hierarchies. The revolution is fractal. NVIDIA NV cell framework applies the same approach at the micro scale. To standard cell layout, the atomic unit of digital design. NVCell generates layouts 92% smaller than or equal in area to those handcrafted by expert engineers, with zero human intervention. Samsung Foundry reports 8% power reduction and timing improvements of over 50% on critical blocks, in weeks, not months. This is the wrapper versus deep AI distinction. Many consultancies today offer chatbots that write TCL scripts for legacy tools, useful for productivity, not transformative. The physics of the chip does not change. Deep AI replaces the optimization engine itself. Agents interact directly with the netlist and the physics engine, making millions of placement decisions through learned policies, not scripting commands. For the enterprise, 3 shifts follow. Embrace the alien layout, the physics-verified result of an agent that does not need human visual order. Treat the legacy design archive as the most valuable IP in the building, and shift the elite team from 50 engineers doing manual layout to 5 engineers guiding a fleet of agents. Moore's law is dead. Reinforcement learning is the defibrillator. The board is set. The pieces are moving. We have laid out the architecture, the proof, and the strategic path forward.